Hello to everyone, I'm Paulo Sorricchio, Master Student at DigiPen Institute of Technology, and with this video I'm going to show you project 2 of CS541 course, Advanced Graphics. Basically in this course we had to play with shader programming, GLSL shaders. In the course we had to use a framework written by the professor in OpenGL and using GLSL to write shader code. Basically in this project in particular we were playing with texture mapping, and I have three examples here to show you. Well, this is just, as you can see, this is just a simple font lighting. This font lighting calculation is performed on the shader, is a per pixel lighting as explained in the previous video. So let's just go and see the other demos. Okay, so the first demo is different textures mapped on the same model, and that is our sphere here. And basically the objective of this particular example was to use different textures for different information. So as we can see here, we have our planet. This is planet Earth, and yeah, okay, so basically we have different textures for this. For what you see right now, you see this is where the sun is. This hemisphere is lit by the sun, and the other one is completely dark. And as you can see, you see lights coming from the cities in the whole world. And if you move the light holding the shift button and the left mouse button, the lights will turn off when the sun is gonna come on this part of the hemisphere, and the lights will automatically turn on the other side of the planet. There we go. And now off. And yeah, that's basically we have one texture. This is just a texture for planet Earth. Another texture is for the sea, because as you can see here, the specular reflection of the fog lighting model is performed only on water surface. As you can see, it's not performed on the land. Right here is really easy to see. Right here you see you see a reflection on the sea, but not on the land. You can actually see the Great Lakes of the US here, because you see the reflection, but the reflection is not done on the land. That is one information. So where the water is, and there was one channel of a texture, because basically we had one texture for, as I said, one texture for just the texture of the Earth, the diffuse color, and one texture that had three channels. On one channel there were clouds, as you can see here, these clouds. On one channel there was information necessary to know where the water was, and on the other channel we had the lighting information. Sorry, not the light. On the other channel we had the information for the lights. So basically when the sun is not lighting this part of the hemisphere, I turn on the light, and that is completely dynamic with the light moving around the world. So this is a first example. It was just to play with texture mapping and having an idea how to use textures, not only for normally we think of textures just as, okay, texture is just a color of something. It's what defines the color of the surface. It's not only. Textures can hold information. That all three of these demos I'm going to show you are going to be how to use textures to actually hold more information. This is what they just than usual. Than what they usually use. The second demo is a bump mapping demo. In the bump mapping demo, bump mapping is basically a technique to add visual complexity without adding polygons. Of course, in graphics, the fewer polygons you draw, the better, because the more polygons you draw, the more complicated the model is going to be, the more calculations the GPU will have to do. Of course, the fewer the polygons, all these numbers will go down. So how do we add complexity? Now you might say here, hey, but you have these round surfaces here, this is going to be a lot of triangles. This is actually not. As I said, bump mapping is a way to increment visual complexity, not actual complexity. As you can see, you can actually see the particles of the model. You see here it's straight, then it's straight. It's not bumpy. You don't see this. You see this bumpiness you see here. If I bring these bumps at the edge, you don't see the bump. So how does it work? Basically, we have one texture that is just this grayish tile, and another texture that is basically just holding information for the normals. So we hold the information for the normals, and what we do is modify the normals at each pixel once we have the pixel in the pixel processor. With respect to the normal texture, it's called the bump map, and we basically modify the normal. We add complexity, but it's just a trick with, again, funk lighting. It's just how the lighting works that it seems that this surface is actually composed by all these bumps, but it's not. This is just thanks to the lighting that we can see it. We are not actually modifying the vertices. We are not adding complexity to our scene, and this is extremely important because, again, the fewer the vertices you have, the better it's gonna be. The faster the whole particle is gonna be rendered. And so yeah, this technique is pretty good. It looks pretty good. We can see on this model, and we can see on the torus model. On the torus model, as we can see here, it seems made out of all these bumps. Oh, even here, look at it's really of bumpy tiles here. And basically, yeah, this is just the model of the torus. As you can see here, you see straight lines here because these are the polygons. We're not modifying the polygons. We're just adding visual complexity, and it's just a trick you can do with lighting equations and modifying the normals of each polygon at each point. Oh, by the way, I forgot to show you that the texture mapping on the Earth demo works with the torus as well. It doesn't really make any sense, but hey, this is our planet. If we leave the torus, that would actually be awesome. If planes would be able to fly from, nah, probably not. Yeah, all the tricks, all the light dynamic lights here are still working, all the refractions are still working. So yeah, so we can go directly to demo 4. Demo 4 is just simple environmental reflection. We're assuming here that the environment is in camera space, so we're always reflecting the environment behind us. And as we can see here from the theory, is really well done. It's really, we can just see the reflection going all around the torus. And again, this works with the sphere, but you know, since the reflection is not in camera space, the sphere doesn't really change anything because we're reflecting what's behind us. And again, the light is always completely dynamic. And yeah, it's probably better shown with the torus model. So this is the reflection demo, and this was just a quick 3 small demos to basically learn how to play with textures and learning that you don't use textures only to bring with you only to store color information. You can use textures for all sorts of purposes, and it's really a powerful instrument. As we said, for example, bump mapping it can save computation time, so that is really important as well. Yeah, so this was project 2 from CS541 course at DigiPen Institute of Technology. As usual, you can go to my website www.parosrikio.com, download this project as the others. Feel free to comment, send me emails, and yeah, I hope you guys enjoyed this video, and see you guys next demo.